All right, hello everyone, and hope you have a wonderful Monday. Welcome everyone to the Gen AI Days. Today marks the start of the second week of the Gen AI Day sessions, and hope you are as excited as I am to listen about the agentic AI stories. Today we have wonderful conversation with Dmytro Zikach and Tatiana Kalavuts. Thank you very much for organizing. I have to admit, we were planning to have also Nazari here as a host, but sadly, we have to wish Nazari great health and speedy recovery, and we are waiting for Nazari for the next session. Today, we're talking about agentic AI adoption, the state of the generative AI as a whole, and we're going to share quite a few success stories from SoftServe. I see we have an amazing audience. Over 130 people have joined. Without further ado, let me welcome Tatiana and Dmytro to stage. Please go ahead and start sharing the screen. Let's hear your stories. Before we begin, as Fina just said, don't be shy. Let's join everyone to the chat box. Leave your messages, comments, and questions. We're gonna have a nice Q&A session right at the end of the call, of this talk, and let me pass the microphone to you guys. Tatiana, Dmytro, the stage is yours.
Thank you, Daniel. Let's start today overview and move forward with agentic engineering, how actually at SoftServe we understand agentic engineering, how we apply, and what actually our results in this direction. Okay, let's move to AI adoption. Tanya, next one. Yep. Let's start with AI and agentic AI adoption because delivery speed, quality, and cost are now strategic, not optional. Agentic workflows actually turn this DLC from manual hands-off into continuous automatic execution with human approval at the gates. In short, complete faster, scale smarter, and keep control. I want to highlight how actually our clients are adopting Gen AI across three key areas. The first one, this is product innovation. Here we see a trend we call agentification. Companies embed agent into their core products so that the product itself becomes intelligent, adaptive, and able to act autonomously. This enhances user experience, drives competitive differentiation, and increases product value. The motto here is building products that think and act. Second one, this is operational efficiency. The trend is agentomation, and organization orchestrate workflows with multi-agent system, which means end-to-end process are automated, not just single task as compared to previous one. This reduces costs, shortest cycle times, and improves decision quality with 24/7 availability. The motto here is automating workflows, not just tasks. And the first one, this is development efficiency, and today we are focused on this one. This is here agent engineering comes in. Development teams work alongside agents that handle the entire software lifecycle, from requirements and UI UX to coding, testing, and deployment. Actually, I hope everyone here try to generate code, I don't know, with ChatGPT, with some tools, etc., to speed up, to write some boring task, etc. And the motto here is building software with autonomous agents. It's not about some copy paste from ChatGPT. It's about autonomous building system and actually how we can speed up building software with applying all this powerness from agentic AI. This can accelerate time to market, improves code quality, reduce technical debt, and increase developer productivity, or decrease it because competency and how you work with tools actually give you ability to increase or in comparison can decrease. And you should be care about technology. You should understand technology into details and apply in the right way. In short, agentic AI is moving from isolated pilots to real adoption in products, operations, and engineering. And today we are focused, as I mentioned, on development efficiency. And let's move. Okay, let's explain how we are redefining the software development process with agentic SDLC when we using agent to automate case steps while still keeping humans in the control where it matters. Because from one hand, SDLC process has best practices, guidelines, and rules, how to implement, how to develop systems, and how to apply and scale all the stuff. When we try to apply agentic and improve SDLC with agentic AI, actually we should redefine paradigm. And let's check how actually we understand this, how we redefine, and what steps we want to include in this concept and methodology. In general, we follow 5 main stages, each with a clear principle and outcomes. The first one, this is design thinking. The first step is about ideas and imagination. And our principle here, prototyping is imagination. Instead of just talking about features, we create rapid prototypes. Often in real time, these keep test ideas early and get feedback fast. And artifacts of the stage, this is early mockups or wireframes, sometimes built with tools like Figma or Cursor, Windsurf, etc. The next one, this is specification. And next, we move from ideas to documentation. And our principle here is code is the specification. That means we use the early prototypes and prompts to generate fast version of the specs automatically. The result is clear and faster documentation that can guide the next stage. And artifacts here, this is mockups and structured specifications. We are ready for generation. Next one, this is generation, and this is where AI agents shine. In principle, specification is the code here, because agent takes the specs and generate production-grade source code, not just mockups or static HTML, but real software that runs. If you're talking about web UI application, it for sure includes not only HTML, some front-end part, it also incorporates backend part, which can be run on some mock-up data, synthetic data, etc. But for sure, it runs backend plus front-end. This is full stack application. And artifacts, this is fully generated software code based on specs and design, which I mentioned before. Next one, actually, we generate code, but it's not the end here. Polishing and testing. Even with great AI, we still need human touch. And if we are talking about ways human we can incorporate in this process, my answer for each step here, we define human in the loop. But for polishing and testing, the last mile is human. Engineers should check the generated code, fix bugs, adjust where needed. Usually, we say around 80–90% is automated, but the final 10–20% still needs a skilled developer to check, to understand details, to operate with some tools who can help in this, and actually finalize code. For example, some pixel perfect, some coverage, security aspects, etc. And the latest one, application can be deployed because real application for sure should be deployed on some environment. This is integration and deployment. Final step, deploying code in the real environment. And principles here, reality is a benchmark. This is where the code meets the client's infrastructure, backend system, and real users. We make sure everything works in production. This step is often the most manual, but also the most critical. And artifact here, code running in production used by real users. So this is new way of building software. Faster, smarter, and more collaborative, combining the power of agent with human expertise. And what else I want to highlight here and keep momentum. Actually, Tatiana from our QC team joining today me and will describe our methodology and results. This fits our theme perfectly. We are not just comparing code generation vendors on paper. We are doing real world QC passing the loop. Okay, let's now look on how we organize team around this new model. What about team decomposition, actually. To compare it to traditional team, we want to introduce a new concept, and we name this by one pizza team. On the left is the traditional team. This is around 10 FTEs. Everyone, mostly everyone, yeah, because we have PM here, coding daily. It includes multiple QA layers and heavy and slow to scale. On the right is a one pizza team. It's approximately around 5 FTEs. Human focus on architecture, analysis, and integration. AI agent handle routing, coding, test, and regressions. UI, UX, QC, PM become lighter and part-time contributions. As results, we can achieve faster cycles, lower cost, and higher consistency. Punchline here, people design the system, agent execute the work. What I want to highlight for you, actually, we are not talking about end-to-end totally autonomous agentic system, because as we can return to AI adoption patterns and actually some levels of autonomy of agent, where level 1 is some solo pilots, level 2 this is some kind of playbooks, when team begin to document, share, reuse workflows, some configuration and prompts become playbooks. To level 3 is networked agents. Here's the multiple agents start running in parallel and communication with each other. Actually, at SoftServe and our Prometheus agent suite, we between level 2 and level 3. Now we are trying to organize all our agent suite as some networked agent, but we require some additional steps to make it happen. And if you're talking about general trends in agentic AI, we can have level 4 as self-governing systems. And in this stage, AI agent enforce standards automatically, bottlenecks are removed, compliance is embedded, governance is continuous. And this is, I don't know, trends for sure for 2024. But for now, we can realize moving from level 2 to next level. This is networked agent. And for these purposes, actually, we for sure should have human in the loop. We for sure should have engineers who can operate efficiently with AI agent, and also roles which can help to understand design patterns, apply the right architecture vision, actually review results which we can have from intelligent engineer empowered by AI agent. Let's move. Okay, solution vision. How actually our agentic SDLC with clear human checkpoint looks like. We start with product manager and requirements agent that turns objectives into user stories and acceptance criteria. A refinement loop keeps scope tight. The next one, solution architect, works with architecture agent to produce the technical design. Some kind of API routing tables, data models, non-functional requirements, and guardrails. Inside the dotted box, intelligence engineers who operate with more powerful code generation agents supervise 3 agents. The code generation agent create codes and scaffolds. The validation agent who enforce standards, and refinement agent fix and diffs based on review feedbacks and following checks. Nothing new. React pattern of building agent system. We write something, validate, refine, and have it into the loop. And actually, for sure, it works. Once code is stable, the testing agent run some, I don't know, unit, contract, integration test, publish consist test report for QC sign-off, approve changes flow to CI/CD agent, which handles build, containerization, environment config, deployment reviews with DevOps. And in production, SRE agent watch it logs, metrics traces, raises issue, and opening PRs for reliability improvements. The key idea, as I mentioned before, and I want to highlight again and again this, people set direction and approves gaze. Agent execute and iterate until the software is deployable and observable. And this is our solution vision. This is so correlated with SDLC best practices, and we want to continue. We not prefer to change a lot SDLC process here because from one hand, this is traditional approach and this works for sure. Sometimes it has the issue, but in general, this philosophy is the right way how to implement and develop software systems. And what we want to achieve, we want to empower experts with agentic AI, with agent, which helps execute and iterate in more quick way. We are not talking today about fully autonomous system, and let's move and understand into details how actually it looks like from UI generation use case, because our real scenario and our benchmark is related to UI generation use case. Let's move. Next one. Okay. What we mean in terms of UI generation? The problem, software delivery is too slow. Teams struggle to accelerate SDLC from requirements to deployment. The solution, use generative and agentic AI with best practices to build a reliable end-to-end pipeline for app generation. And impact here, faster delivery of simple moderate apps, less human intervention, and higher developer productivity. As the drivers are clear, rising demand for speed, affordable compute, fast-changing tech skills, and pleasure to cut software cost. And in terms of some vision, next one, I don't prefer to describe into detail this huge scheme because this is map of agentic SDLC to UI generation. We have some planning stage, turns PRDs, meeting nodes, schema to some goals, user stories, some criteria. We have code generation agent, which converts schema specs to code, operate with storybooks and validation agent, testing agent, CI/CD agent. We defined two loops, keep quality high, automation refinement, agent fix failing checks, and designer dev refinement, approve and merge. And output remain tangible. GitHub PRDs, Jira updates, storybooks links, and quality dashboards. So UI work is measurable, repeatable, and fast. You can check into details this slide, but I not prefer to describe a lot about this because let's move to main part of our presentation. This is code generation benchmark. In this benchmark, we explore different types of coding solution. Next one, Tanya, please. First, we have CLI-based tools like Claude Code, OpenAI Codex, Gemini, like if you operate with them. These are command line agents where developers give structured prompts, get code to back, often integrate results directly into IDEs or pipelines, and they are flexible, but require more technical handling and context setup. The next one, this is UI-based tool. This is like Builder.io, Devin AI, Cody. These tools provide more guided workflows, dashboards, templates, or project scaffolds, making them friendly for product teams and non-specialists. Reduce friction, but sometimes trade-off flexibility. And finally, to make benchmark fully, we bring in our this benchmark SoftServe Prometheus agent suite. This is designed specifically for enterprise workflows. We integrated requirements, architecture, code generation, validation, and refinement into one orchestration flow. It's not just code generation, but full SDLC automation. And how we did select these tools? We looked into diversity, mixing big model vendors like OpenAI, Anthropic, Google, specialized coding assistant, and end-to-end builders like Devin, Cody, etc. And the idea was to capture different approaches: low-level code agent versus UI-driven assistant, and versus enterprise-grade agentic system. This way, the benchmark reflects a balanced spectrum, from developer-first to team-friendly and to enterprise-ready. And Tatiana, can you walk us through the benchmark setup and how we kept it fair?
Yes, of course. So I would add here that the main idea basically was to compare all this generation based on these mentioned tools, and they should be measured in some different but the same ways, with the different ways but the same stats, such as like number of iterations, generation time, the backend and the visual correspondence, the amount of tokens that we spend, some SonarQube stats, and some specific model issues. And of course, the results should be approved and accepted and compared for the next iteration. And it could be a refinement, customization, or roadmap usage. And basically, we compared and evaluated all the results in the similar way with the similar parameters. So I will move to the next slide. So as I said, to generate the web application, we need to have some input data. In our case, it was Figma designs, basically, that we use for testing, for generation. You may see here on the slide the part of the application that we need to generate. We had 4 views, 2 pages, and 2 models to be generated. And of course, it was like notes and screenshots. Notes, basically some components such as pagination, time range filtering, search bars, some charts, lists, tables, and so on. Of course, we need some specification to be used to generate the good quality results. You may see here the part of our specification for each component with the full description. Data model, of course, we need to have the data model to have a full backend, and you may see here the part of the container and all the parameters that we use for generation, and of course some structure rules, high-level rules, and text tag for data generation. And of course, we get to the first step, first phase. We call it one-run generation. Basically, we took all this input data, we took the agent and generate the web app application. If you talk about the process, it's pretty similar and simple. So we have some dev team who analyzed and run through the generation process with the tool, with all these inputs that I mentioned, and we generated the web app based on the specific model. Then, of course, we need to pack the results to compare and to analyze them, and we transfer them to the QC team, and we have the evaluation process that I will mention later in the details, and we generate as like artifact, we generate the report and include some cost evaluation, SonarQube results, and then we compare all the results for each model, and basically we summarize the results to compare and to pass to the next iteration. If we talk about experience setup, what we had the Figma designs, its images and links, specification, data model information. We have the SQL database with mock data for testing, for generation. We have the code generation tool. Basically, it's our agents such as Claude Code, Gemini, and so on. Text stack and structure, and SonarQube. That, like everything that we need to generate the web application. And as output data, we expected to have the front end of the web page with all the mentioned views. It's like code repo. Also the backend code, which operates with mock data for the testing purposes. And of course, a summary, it's QC report with all the compared results. If we talk about generation itself, you will see the full video here. It's quite big, but generally you may see the prompt, the part of the prompt that is mentioned here. And once you run it with the agent, you can generate the part of the web application. Basically, here on the video, you may see the first page. And then once we archive it, we move it for the QC team to set up and to compare results with the Figma, with the expected behavior that is mentioned in the rules. And then we go to the step 2. Of course, each application should be validated. So we define the methodology, how to compare all the results, basically different tools in the same way. We have 2 steps validation. First one is this backend part, and it consists of 2 steps. The first one is validation test. Basically, we need to check if the buttons, filters, all the elements are workable. For example, if the search is performed, if it's on the backend side, if the functionality works as expected. And the second part is basically the backend integration. We answer the question, does the backend actually works and is it correct, integrated with UI part. For example, here you may see the part of the report, basically is general table for builder IE. We have the 53 checks, functional tests, and you may see that coverage for the builder was like 21%. That like we can say that 21% of the functionality checks was working well, but of course most of the checks were failed. Here you may see the examples for some of the agents. On the left side is Gemini. You may see that some critical parts were not working. For example, here is just like removing or editing the container. We get the error and we cannot say that functionality. It's important to say that it's critical functionality and it doesn't work, so we cannot pass these tests. And comparing with the Code, the same functionality works well and user can reach to the main goal, for example, add some container, edit it, delete, search for container or filter it. And if we talk about the high-level summary for both of the agents, we can say that Gemini is quite good generate the UI part. And for example, if we compare it with Codex, it's better, but still it shows the average results for the backend part, for the integration, and you may face that some critical, really important features doesn't work. If we talk about Code, it gives us quite good results with generating the backend part, and the UI part was quite acceptable. Of course, it's not very good quality, but still it's acceptable and we can verify it with our expected results. The next step was front-end validation. Basically, how accurately the input data recreated in the UI. And it's difficult to compare the agents just with amount of bugs because if we divide the bugs to the priorities like high, medium, and critical and low, still we won't have the overall results for each agent. So we define the strategy to evaluate the front-end part by different parameters. Basically, it's total mismatch, partial, exact, and blocked. How visually the generated pages and their components are acceptable and can be tested with expected results with the Figma. So the total mismatch was when the element is like entirely doesn't match with the expected result. Partial, when the element is partially matching, for example, slight styles changes, maybe sizes, different sizes, and so on. Exact, basically when the element is fully matches with the designs. And block, sometimes we faced with the issue when we didn't get the element or page at all, so we cannot compare the part of the functionality, or the element, it cannot be tested at all because, like, for example, another element overlaps the required component. And here you may see the part of the also the part of the report for the visual fidelity. So we divided each mockup for the components, and it was like 66 elements. And you can see here the results for the Devin. For example, only 5 of the elements were exactly matching with the designs. 41 is partial. We have the 20 as total mismatch, but 0 as blocked. As example of the total mismatch, you may see here on the top of the screen the mockup. The part of the mockup, it's basically the element toggle for filtering the alerts and clear filters button. And what we have in the result of the generated application, you may see that it doesn't match at all. On the right side of the screen, you can see the blocked part. Basically, we expected to chart to be generated, and on the bottom of the screen, you may see that chart wasn't generated at all. So in this case, we cannot compare the visual fidelity. We cannot compare the functional tests if it works, because we didn't get the expected result. As a partially covered, you may see the example with basically status chips. It's almost the same, but we have slightly difference in the colors, so we can treat it as partially covered. And exact, you may see the totally matching create container button, so we treat it as exact matching button. Of course, as I already said, we need to think about the code quality. So we use the Sonar Cube. And the main approach was just to assess the quality of the generated code by the defined metrics. So the metrics was were security, reliability, maintainability, security hotspots, and code duplication. And we pass it for all the agents. And we took just issues with rating A. Basically, it's high priority issues to highly and brightly show the comparison between all the agents, how many backend and frontend issues we got within the generation. For example, on the bottom of the screen on the left side, you can see the Claude Code tool results, and compare it with Gemini. So the backend part was really difficult for Gemini, as I already said, that we get a lot of issues here. But frontend part is almost the same for Claude Code and Gemini. And on the right side of the screen, you can see some screenshots from the Sonar Cube. Basically, the division to the different type of issues, the list of and examples of the issues that we get during the generation.
Yep. A couple of thoughts from my side. Why we are talking here about Sonar Cube? Let me showcase for you philosophy and main idea of why we actually incorporate the stuff. When we generate or try to answer for some questions with LLM and receive some answer from LLM, it can include a lot of hallucinations, issues, etc. And we pretty known about all these issues, bugs, etc. Because this is LLM and hallucinations. This is main key point from LLM. Yep. This is generative algorithm for sure. But if we have a result from LLM and pass this again to LLM and ask about some improvement, in general cases, it works when we try to generate answer with some smallest model and use LLM as evaluator bigger one. For example, Sonnet versus Opus or Sonnet versus GPT or Gemini, etc. But with code generation, it doesn't work because Opus isn't give a huge difference to be actually deep reviewer of code generated by Sonnet, for example. And our idea, for sure, to move from end-to-end LLM solution for code generation and reuse all best practices from SDLC. And SonarQube, this is general tool which give proper understanding of quality of code base. And it provides for us details regarding different metrics. It's pretty understandable for software engineers, for traditional teams. And when we are talking about some quality of code which we generated with agent, we can provide an easy way SonarQube reports and describe into details what issues we can have with generation and what we have as greatest part of applying agents. And for sure, SonarQube, this is one of main evaluation techniques in our benchmarks. As Tanya mentioned, this is from visual fidelity, this is from SonarQube measurements and also code quality. And we are not measure our results only as LLM as evaluator. As you see, we have QC, we have SonarQube. We want to reuse all best practices from SDLC process, and actually for us it's crucial not only generation code, we are also thinking about adoption agent into traditional SDLC process, and actually we want to reuse all best practices. Let's move to next one.
Yeah, I will just note that it's important to filter out the duplications from the SonarQube because, for example, Claude Code may have, I don't know, 10 backend issues, but most of them are similar. So you need to analyze them and get just the unique issues to compare the results between the agents. Yeah, so I will go to the general results.
Let's highlight in very high level. I can help you, Tanya.
Yes.
Actually, you can check into details this table, but what I want to highlight as action items. Yep, Claude Code performs well for prototyping with good coverage, but struggles with some front-end details. OpenAI Codex and Builder.io shows very low coverage and high blocks rates. Actually, you can use this for first step of SDLC process to check some, I don't know, Figma design, etc. Try to implement, but in general, you will receive not ready application for next steps. Gemini improves compared to OpenAI Codex, but still falls behind on fidelity. Devin AI generates solid backend, but lacks with UI and comes with the highest code. Cody, cheap and fast, strong for backend generation, but needs help for front end. And also our SoftServe Prometheus agent suite. I don't want to highlight this as 100% because it's not the final agent suite which we applied here, but it's good start to reach actually strong visual fidelity and balance and backend front-end quality. And key takeaway, actually with Prometheus, it's not only tools that delivers enterprise-grade reliability, other serves niche cases like fast prototyping or backend-only task. What we want to highlight for you more today, and let's maybe speed up sometimes, we want to give for you real examples, how actually it looks, and move to lesson learn, what actually we achieve and how we improve all the stuff. Tanya, push forward.
So as Dim already said that as example, we can compare here the Devin for example, on the left side, you may see the Figma mockup and generation itself with the same page, but with using the Devin tool. And you may see that it's like not so good. We have not so good quality. And you will see this in the results in the main table. So if you need to have the high quality UI, of course, you need to use another tool. For example, also with Cody, you may see the Figma mockup and create new container model. It's acceptable, but of course, we need to have some slight changes for the styles. And we get to the lesson learned. Basically, after the first generation, we filter out the models that Dima mentioned, like Devin, Gemini, and Builder. There is no sense to improve something because we won't get the perfect results, or at least acceptable results. So we took some tools from this list and decided to have some experiments how to get the application better. And one of the approaches was the roadmap. Basically, the roadmap, it's like type of the generation when we use the additional context that is very like structured plan of action, and we use it for generation. And on the right part of the screen, you can see the roadmap generation process. We use Devin for generated, and then we just put it to the generation process, the certain rules of actions. And you may see some some common results here for Devin, for Gemini, for Claude Code, for Codex with GPT. You can see the difference between generation with roadmap and just simple generation. And in most cases, it gives us better results. Not very big, but like not very big difference, but still, especially for Codex, it gave us really cool degrees. And as example, you can see here, again, the Figma mockup, the simple generation for the Devin tool, and how it looks like with roadmap. Of course, it's not the same. It's not exact matching, but still it's better than just simple generation. The second part or like step as lesson learned, it can be refinement. Basically, this generation procedure is like initial result that is improved through the several edits. So the refinement process is limited by 3 prompts. On the right side, you can see the example of the prompt for simple generation and the prompt with generation with refinement. So the main idea was to have the simple generation, and we compare all the results. We filter out the models that can be improved, review the artifacts, and we include the refinement or roadmap, or I will tell you later about customization into the process, and we generate the web application based on the specific model, including the refinement. Then, of course, we need to test the results and compare it not just between the last generation, but compare it with simple generation. Basically, the measurement, the difference between the received stats. And of course, we include the same stats as costs and SonarQube results. On this slide, you will see like the overview of generation. With refinement, it's very long, so I will describe it in few words. So basically, there's like several tries. You can take just one or all the views, all the mockups, and generate it with a refinement prompt, and then compare results with the simple generation or with Figma. And here you may see the overall results for two of the tools, Claude Code and Cody. So you can see the difference in generation without refinement. Basically, it's simple generation and generation using the refinement prompt. You can see, of course, not very big difference, but still we get better results, not just in backend part, but in the visual as well.
Yep, what I want to highlight here actually, if you define two steps generation, the first one generation from scratch and second one try to improve, actually context window play with your game and it not so productive. As you see, refinement can add you some percentage of coverage. For example, you can fix some blockers, critical issue, etc. But it can't for you change totally situation. But in general, if you have some directed issue to some parts, I don't know, to some form, graphics, menu, etc., you can try to fix with this one. Be careful because you operate with huge context when you refine some functionality of your application, and it can have place here, but for sure you should be so deep dive into details to check what actually you refine, what files actually are rewritten by tool, what actually code you change, because you can be so surprised regarding this one. Regarding in compared to roadmap edition, when we are talking about third-party application, looks like for sure this application includes some roadmap or implementation step. If you play with Cursor, you can have the same with Devin AI. When you ask to generate something, it provides for you some roadmap, you approve and move forward. If you are talking about CLI tools, for sure it's better to provide roadmap what you actually want to achieve with generation step, and this for sure can be totally changing situation, because sometimes CLI tools is struggling with generation, what it provide very huge batch of generation step, and actually it can help them. And in general, this is the same. If you want to achieve some results from junior or middle level software engineer, you should provide clear steps with clear explanation, requirements, details, what you want to achieve from middle level software engineer. The same with LLM agent. Be not surprised. This is the same. You should describe steps, describe what you want to achieve, and in this case, you can be successful with all the stuff. Yeah. Tanya?
Yeah, and again, if we talk about the roadmap, it's not only about to generate the roadmap and take it to the generation, but of course, as a human, you need to check it and, for example, filter out some unnecessary steps or actions, or you need to be sure that it won't overlap the existing already added rules, because you may have in the results not so good quality, because like the tool cannot decide what to have in the end, because we have totally different rules described in the prompts and in the roadmap. So yeah, as example, of course, with refinement, we can take the Cody tool. We talk about just visual fidelity here. You may see the Figma mockup on the left side, just the simple generation and generation with refinement. And as we already mentioned, we didn't get totally different results, but you can see that slight changes were here, and it's more it has more quality than just simple generation, but again, not totally different results. And the third part is lesson learned can be the customization. It was also part of our experiment. Basically, this type of generation uses the Figma MCP, which provides the additional context from Figma styles, including the icons, like the colors, font sizes, font types, and so on. We can include here the example of Code tool. You may see here the results for simple generation and compare it with MCP. Again, we get not the big difference, but still the coverage will be bigger and the visual fidelity is also bigger. But also we can know that it could be specific by model. So you may see the difference and the logic for each model, that it will give you, for example, just 2% for coverage, or sometimes for different models we get like plus 10. And as example, you can review then the simple generation prompt for the pagination component. Basically, the prompt with components, you can see here the description of the pagination component and the example, like the description of the component itself. It's very detailed with all the rules and all the styles that need to be applied. And as example here, you can see the Code tool again. On the left side, Figma mockup, the simple generation, and you can see the generation with the MCP, the difference between these three mockups. Dima, maybe you want to
Yeah,
add?
actually, we follow MCP concept to organize all results which we can incorporate as additional tool to code generation process as MCP. And actually, we have a couple of MCPs which give for us some inputs for the code generation agents. And as examples, this is MCP which operate with Figma directly and can, based on component which we defined for generation, get details from Figma and prepare the right input to the agent in a markdown file with all details related, how actually component should looks like, what is the size, fonts, colors, etc. And we are trying, when we have final logic regarding some step, we incorporate this into tools, packages as MCP. This give for us opportunity to be more custom and also support other code generation tools in the future. Because for now we operate on top of Claude Code mostly, but for sure this MCP concept and give for us ability to incorporate our results in Code or Devin AI for the future and make it more simple. And we try to incorporate some additional logic of pre-processing from Prometheus agent suite, connect this to Cody, Devin AI, and actually run how actually it can give for us much more pretty result. Tanya?
Yeah. Just as conclusion here, I want to add that we also get some experiments with combining the MCP with refinement, with roadmap. But of course, we need to have the big human impact here, because we need to really check not just outputs, but the inputs as well to have the better results. So basically, it also can be the refinement plus roadmap, and you can compare the results of all these experiments as well. But still, we need to think about that, like, agent has specific issues here. And also we really need to filter and analyze the inputs from our side with roadmap, with refinement, MCP, because still it can overlap the rules, and sometimes we get totally bad results because we try to combine all these scenarios in one, and it wasn't very good for quality. And we get to the last part of the conference. It's basically Prometheus that we little bit described in the beginning.
Actually, we want to showcase for you how actually from visual fidelity looks like generation by SoftServe Prometheus agent suite, what actually metrics we have in compared to other methods, and you can check into details all numbers. But I want to highlight a couple of important thoughts here. Actually, as I mentioned before, we are not building fully autonomous system. We have for sure human in the loop, software engineers, etc. And what is crucial for us to handle total mismatch and block it visual fidelity. And this goal we for sure achieve it, because we are not talking about some pixel perfect, about some quality on different devices, etc. Our general approach, if middle level developer front end or back end can handle the issue in 1 hour up to 2 hours, we prefer to skip refinement from agent perspective and give ability for software engineer to rewrite and make it happen, because for sure we require code assessment, look from developer perspective to check reports which provide SonarQube printers, etc., and finalize application and be ready for deployment stage. Also, it's a lot of questions regarding some issues related to production scale, large scale applications, etc. My answer, we are not talking about this yet. This is iterative process. We started this year with code generation cluster at Gen AI Lab, and actually step by step, month over month, we want to improve our solution. We started with UI generation for backend system when we changing totally our approach for some demo purposes, because for now we are not using Streamlit as application and a library to provide some demo to the client. In easy way, based on Prometheus agent suite, we can generate to ready backend written by our experts on the project, so we can generate UI and connect them together, and demo looks like much more nicer than you can create with Streamlit in the same time range, 1-2 days. Also, we set up at one pizza team concept. We have Ira Kovalchuk who oversees this activities, and for now we have billable projects as well when we are applying Prometheus agent suite, and we move forward step by step. We move. For now we pretty done with UI generation. We have project related to mobile development, and not only Python with React, we actually add much more programming language which we support. Actually we move forward. Daniel.
Yeah, just as note, sorry, you will see in the end of the presentation the general results with refinement, without refinement, and you can look through all this coverage, all this fidelity comparison.
Yep, a general umbrella of our suite. It's a lot of different agents for different purposes, but we are moving forward. Daniel.
Great. Excellent. Dima, Tanya, thank you so much for presenting. It was really interesting to hear about these new advancements that we have in SoftServe. To respect everyone's time, because everyone might have following meetings, I have just saved this chat and we will respond to all your questions in offline. So please wait for the follow-up. Might just tackle just one question. From the very beginning, I really liked the one by Julian. Should we create an app just from a UI design, not from PRD, from some research? As you mentioned before the presentation, the specs are the new code. Who would answer? Nima?
Oh, maybe I missed a lot of question. Yeah, actually, I remember this question. Why we benchmark only code generation purposes? This is, I can answer in easy way. When we want to benchmark huge system, which can a lot of steps, actually we should define the right one, what is so crucial and urgent for whole system. And based on our agreement and based on projects and based on our experience, actually code generation, this is a ML part of AI system when we have a lot of data layers, deployments, etc. And when we are talking about code generation, the code generation agent directly, not the huge umbrella, this is crucial part. And our mission was to understand what the right tools on the market for this. Did we make the right decision about moving with Claude Code and build Prometheus agent suite on top of Claude Code? And for this purposes, we for sure predefined outputs from BA agent, requirements agent with inputs required as Figma, specification, data model, routing table, and also, and actually we apply different tools to generate code, and we try to assess all code related to our tools and organize all the stuff together. QC part from Tanya side, SonarQube from code, and linters from code quality. Daniel?
Great. Excellent. Thank you so much, Dima. Thank you everyone for joining. We really wish to spend a lot more time with you all but you have opportunities to join us to the next sessions of GenAI Days. So please follow the schedules. Look forward to seeing you all in the next session of GenAI Days. Thank you so much and have a great week. Thank you.
Thank you.
Bye-bye.